kinematic equations that we use?
Vf equals Vi plus T.
Okay.
Hello.
V equals V naught plus VIT plus 1/2 AT squared. I'll let you handle.
No, it's like VF squared.
Right, Vf squared equals Vi squared plus 2A D minus D naught. All right, in linear terms, I have kinetic energy. So this is called translational kinetic energy because I am translating across the ground. Underneath the center of mass is actually moving, and this is going to be 1/2 mv squared. I have momentum. P equals mv. We have, how do I change momentum? What's change momentum called?
Impulse.
Impulse. And so what are the two halves of the impulse equation?
Time, change in time equals Newton's velocity.
Right? So that's impulse. What is Newton's second law?
F equals ma.
F equals ma. So what other variables do we have in here? Well, I've got an m in here. Right? P, but that has mv, so I'm doing that. Mv squared, ma, m was the only other new variable. Right? All right. All of these deal with linear motion. So let me ask you, what is mass? What is mass?
Okay.
Go ahead, Osman.
Resistance to linear inertia.
Almost. So close, because you would apply it right, change. Mass is the resistance to change in linear motion, i.e., what is Newton's first law?
An
A
object.
body in motion stays in motion. I don't need a force to keep it going, right? Because it is in motion, that is a part of the characteristic of that object. That's what we use to describe it, and it just goes. Now, to change how it's going linearly requires a force. All right? That's where that difference is going to come in. So mass is the resistance to change of linear motion. Now what we are going to deal with is, shoot. Could you go get the wheel?
Yeah.
From next door? Instead of doing linear motion, we are going to do angular motion. And the major thing to understand is that in linear motion, the wheel that you turn stuff in on. Oh, we could have used that one, but I'm lazy. I just want one that I can sit there and spin without having to hold it. And so we have something actually called the wheel.
Oh, yeah.
And for those who take AP1 and actually get the privilege of being in that room, you actually turn your stuff in on the wheel. It's called the wheel. That's why it's the wheel. Yeah, that one. All right. Now, when I have this particular thing set up here, all nice and neat, all right, and I'm spinning it, relative to the room, is it actually going anywhere?
No.
No. Relative to the room at an instant in time, is this mass, which I can unscrew and take off and everything, so is this mass going somewhere? At an instant in time, does it have a linear velocity?
Yes.
Yes, and wouldn't that be tangent to the motion? That if we took the snapshot when it was right here, it would be going that way?
Yeah.
If I waited later and took it here, right, it would be going that way because it would be tangent to the circle that it's on, right? So I have angular motion, which means it's not really going anywhere. And yet when I have angular motion, my particles, my individual pieces of mass, do have linear motion instantaneously. All right? But what we want to do is do this as a collection. What is happening to the wheel itself? All right? So is there not, if I start here and I go once around, is there an angular distance the wheel has traveled? What is that angular distance the wheel has traveled?
300.
2 pi radians. or
360 degrees.
360 degrees, or 1 revolution. Okay, so now there are 3 different languages we're speaking. Because isn't the difference between languages just the particular combination of sounds that make words, that make the meaning of that word to be the same meaning as everything else?
Yeah.
Right? Languages is a collection of words, which then words are just a collection of sounds. Right? So 2 pi radians, 1 revolution, 360 degrees. Aren't those just 3 different languages? They all describe the same thing. That make sense? So I need you to be able to speak all 3 languages and interchange between them. All right? Out of those 3 languages, which is the SI language? Radians. With a better pronunciation, yes. We have the country hick accent, Radians. We're from Texas. All right? So, radians. Now, how is a radian defined? Mathematically, what is the definition of a radian? It's an angle such that angle theta is equal to, this is the distance around the arc that you're traveling, and that's S. This is the radius of that arc, and theta is S over R. So please understand, the unit radians does not exist. Because S would be measured in, it's a length, it'd be measured in what?
Meters.
Meters. R is a length, it would be measured in?
Meters.
Meters. So I'd have meters over meters, some number of meters over some number of meters. Yes? Meters would cancel. What unit is left over?
Nothing.
Nothing. But because human beings don't like naked numbers, we put a unit to it. And the unit the mathematicians decide to put you to that naked number is called a radian. But radians don't actually exist. All right? So, my angle, it is the measure of how far around it goes. All right? So, over here, I have theta, a theta naught. It's the angle of travel. All right? Velocity. Well, is there a difference in the speed this is traveling around between that or that?
Yes.
Right? That means we need to be able to represent that speed. Well, what would be the units of this speed? What would be the SI units of this speed?
Radians per second.
Radians per second. Right? That's the SI units. Of course, radians don't exist, so the actual unit is per second. Ooh, what's a per second? It's a frequency. It's a hertz. Correct. All right. The letter we use then is I have an angular speed, omega I, or an angular speed, omega F. Right? And if I did omega F minus omega I, what would that be? Change in omega, because final minus initial is the definition of change in anything. Are we good so far on that one? All right. Can I change my omegas? Can I go from omega I to omega F? Wouldn't that be an acceleration? And there is an angular acceleration in radians per second squared, and it's given by the letter alpha. All right? In terms of angular motion, because this is angular. In terms of angular motion, what would we do for time? Yeah, it's just time.
Make that little T a little, make that T a little more curly. Yeah. Still time.
But it's still just time.
Yeah.
All right. What would mass be? What did I ask originally? And he answered it almost perfectly. I asked what was mass, and what was the definition of mass? Resistance to change in
Motion.
linear motion. So if I'm going to put mass, I'm going to put that in quotes, if I'm going to put mass in my angular column, what would be the definition of that mass in the angular column? Resistance. Okay, I'm going to repeat what is mass. Mass is the resistance to change in linear motion. What is the angular equivalent to mass? Thank you. Resistance to change in angular motion. And it is called moment of inertia, and it's given a scripted I. This is called moment of inertia. Now, moment of inertia has a couple of different things to it. And unfortunately, they ripped apart my master's on the end of the meters.
Who did that?
Regular physics. It,
It happened to-
well, right, it happens, yeah, when I let non-students in my classroom. It's sad. Okay?
What did they do?
We had demonstration equipment made and they ripped it apart. Simply because they could.
Science.
I don't know. All right?